Hello my dear friends, I am here now to discuss with you a new chapter, and the name of this chapter is Chemical Thermodynamics. It involves two terms my dear friends. What is the first one? Chemical. What's the second one? Thermodynamics. So my dear friends, before I actually start up with the concepts involved in this particular chapter, let me first of all make you very clear what does this chemical thermodynamics is all about. So to begin with, we start with the first word, and that is what? Chemical. When we talk about chemical, the very first thing which comes into our mind is what? Obviously, it's chemistry. So chemical means it's chemistry. Now my dear friends, you have been learning chemistry from a long time now, at least 2 or 3 years. Have you ever thought of a chemistry without a reaction? No ways. So chemistry means reactions. Now when you talk about reactions, the very first impression what you get when you talk about reaction is it's reactants getting converted in products and etc. etc. But then if I want to represent this reaction in terms of only a single word, I would just simply say that it's a process of change. So reaction means it's change. Now the next question which would be going on through your mind is change. What type of change is he talking about? I'm talking about with respect to a substance. Now whenever I consider a substance, there are two concepts associated with it. Number one, it's its physical state. Okay, it can be solid, liquid or gas. There can be plasma, superplasma and so on. But then we are limiting ourselves to only 3D physical states. Solid, liquid, gas. And the second one is what type of a chemical it is being made up of and in what proportion. And that is chemical composition. So two things my dear friends associated with a substance. One, the physical state, and the second is its chemical composition. So when I talk about change, what type of change is actually taking place as a result of which the reaction is being bifurcated into two categories. Number one, and that is, we talk about a physical reaction. Alright, what we talk about is a physical reaction. Now, in a physical reaction, what you want you to understand is that I write down as PS, okay, that is physical state. I put a tick mark, that means yes, okay, and I also write down in bold letters only. So what does it imply? Yes, I guess you're smart enough to understand this. So physical reactions are those reactions which involves a change only in the physical state. So that means if I say CC, chemical composition, I put a cross mark. So that means there is no change in the chemical composition. Only a change in the physical state. That means a solid getting converted to liquid or a liquid into a gas or a solid into gas, things like that. Okay, the next one is we talk about, and that is called as a chemical reaction. Now as the name suggests, it's a chemical reaction. So it's very obvious that chemical CC, chemical composition, I need to put a tick mark that yes, there is a change in the chemical composition. But then the very next question which will come to your mind is, alright, what about the PS? What about the physical state? Hang on, I'll tell you. For PS, I'll write down as this or this. Right? Smart enough you and I know what you mean, and that is the tick mark, that means yes, there is a change or no change. So physical state may or may not change, but there will be always a change in the chemical composition, and that is nothing but it's a chemical reaction. Alright, so I guess you are being very clear with the differentiation between a physical reaction and a chemical reaction. Right? Now we go to the next one, and there is thermodynamics. Now let us try to be as simple as possible, my dear friends. What do we do is, thermodynamics is we split up into two terms. Okay, that is one is thermo, the other one is dynamics. When you talk about thermo, my dear friends, the first thing which comes to your mind, and that is nothing but what? It's heat. Okay? It is what? Heat. And I guess every one of you knows this very well, that heat is a form of energy. Yeah? Because I got very smart audience, I know that. Okay, so you know this very well. Heat is a form of energy. Now coming to the next term, and that is dynamics. You must have heard about static, dynamic. Okay, these two are opposite terms. And you also know static means what? Stationary. Okay, where it is. Okay, there is going to be there. It's not going to move around from here and there. It's rigid. So that is what the static is. And as I said, dynamic means it is opposite of static. So it's very common sense. Dynamic means what? It's something flow. So dynamics means we say it is flow. Getting it? So now you club. Thermodynamics. So it's what? Flow of heat energy. It's as simple as that. But then the chapter is chemical thermodynamics. So now if you club all these together, we arrive at a definition of chemical thermodynamics. And that is nothing but chemical thermodynamics is a branch of chemistry. What it is? It is a branch of chemistry which deals with the flow of heat energy taking place during a physical and a chemical reaction. Getting it? Okay, once again I repeat, it is nothing but, what is am I defining right now? Chemical thermodynamics. It's a branch of chemistry which deals with the flow of heat energy taking place during a physical or a chemical reaction. Okay, and this is what the chemical thermodynamics is all about, and this is what I want you to understand before we go into the concepts of this chapter. Am I very clear? Oh yes. Okay, my dear friends. Now once we have understood what exactly chemical thermodynamics is all about, so now we begin with the different concepts of this chapter. So to begin with, we are going to start with the basic terms. Now in the basic terms, you must be knowing it very well, that the largest form is being called as universe. What it is called as? Universe. So let us now assume that this is a universe. Let us assume, obviously, it cannot be so small. So this is a universe. Okay, जो कुछ भी चीजें समाई हुई है वो सब यूनिवर्स के अंदर है. यूनिवर्स के बाहर कोई नहीं है, ऐसा हम मानते हैं इस पर्टिकुलर चैप्टर में. आई बात समझ में? Alright. Now what I do is, I mark a particular area like this. ऐसा. Okay, ये इतना एरिया में मार्क कर देता हूँ. ये रेड वाला दिख रहा है आप लोग को? यूनिवर्स का ही हिस्सा है वो. Alright? But then, this is what I have marked. So it is something which is specified. I have marked it, so that's why it is something which is specified. Now I am going to consider this with respect to the thermodynamic point of view. Now, आपके दिमाग में सवाल आएगा, thermodynamic point of view means what? I'll explain it. There are 4 primary properties which are related to thermodynamics. You must have heard about this. I'm very sure about it. The first one is temperature. The second one is pressure. The third one is volume. And the fourth one is composition, or I call it as concentration. T, P, V, C. So these are the 4 primary properties which are related to thermodynamics. Now I give 2 names to these properties. Why? I'll give you the reason also. Okay? The first name is, I call these as variable properties. What I call it as? Variable properties. Now why? Variable, this term is very clear to all of you. Why do we call it as variable is? Because the one which is going to change with time. Okay, temperature value. I give you a very simple example so that everybody can relate with it. सुबह 5 बजे जो टेम्परेचर होगा, क्या दोपहर को 12 बजे भी वही टेम्परेचर होगा? क्या शाम को 6 बजे भी वही टेम्परेचर होगा? क्या रात को 12 बजे भी क्या वही टेम्परेचर होगा? नहीं, वक्त के साथ वो बदल जाता है. तो that's why we call it as variable property. Alright, so it's the same thing as with pressure, volume, concentration, etc. Okay, these properties have values and these values can change with time. Okay, and that's why the name is variable. The next point is, okay, and that is, I give you 2 simple examples. Okay, 2 cases. First case is, I give you a room and I tell you that in this particular room, please record the temperature at intervals of 1 hour. And tell me, what is the change taking place? And I give you the same assignment, but this time not with a room, with a minute particle of a chalk. My dear friends, पूरा chalk नहीं, उसका एक छोटा सा कण, particle का मतलब होता है कण, वो देता हूं मैं आपको. और आपको बोलता हूं कि इस छोटे से चौक के कण में टेम्परेचर में क्या बदलाव हो रहा है हर घंटे में, वो मुझे बताइए. So these are the two cases. Now if I ask you whether the answer is going to be accurate, yes, I'm very sure you are all going to tell me this. I can hear also the answers from you, that you all will say that, sir, from the room, the whatever observations which are there are much more accurate as compared to a small particle. It's not that in a small particle there are no changes in temperature. There are. But because it is so small, it is very difficult to accurately note it down. But here in room, it is big. So accurate observation is possible. I specify on this word, accurate. And that's why that big part, the large part comes into the picture. And because it comes into the picture, the next word for this is macroscopic. What we call it as? Macroscopic. Macro means, you know, it is something which is large. So these are the two names given to these properties. Which are those? First one is variable, because these properties are characterized by their values which can change with time. And the next one is macroscopic, because their values accurately depends upon the large amount of the substance. Concept is clear? Very good. So this is the primary thermodynamic properties. So coming back over here, this is what? Can you remember? Forgot? I'll tell you. It's universe. Now I mark this area. Now because I marked that area, that means it is a general portion or a specified portion? Yes, you guessed it right. It is a specified portion. Of what? Universe. But it is under thermodynamic consideration. That is, it is with respect to these properties. And I call this as a system. What I call it as? System. So what is system now, my dear friends? It's nothing but it is the specified portion of the universe which is under thermodynamic consideration. What is it? It is with respect to what? Thermodynamic consideration. And thermodynamic consideration means what? These four properties, that is T, P, V as well as C. You getting it, everyone? Okay, this is what system is all about. Now come back over here, my dear friends. This entire is universe, small portion of which is a system. What about this one now? This is also the area. This is also part of the universe. It's not a part of the system. It's the remaining portion of the universe. And this, I call it as what? Surrounding. What I call it as? Surrounding. Okay, so how I need to define surrounding as? Yes, I'll do that also for you. Okay, and that is, it is the remaining portion. Obviously, of what? Universe. Now, is it going to include system? क्या इसने सिस्टम को शामिल किया है? जी नहीं. और जब शामिल नहीं किया जाता है, ओके, और उसे हम लोग क्या बोलते हैं अंग्रेजी में? Excluding. What do we call it as? Excluding. So it is excluding the system. Okay, getting right? So surrounding is the remaining portion of the universe, excluding the system. Okay, that is surrounding. So now if I ask you a question, system और surrounding दोनों को मिला दिया जाए तो क्या मिलेगा? Very good. बेहतरीन आंसर है आप लोग का. You are very smart audience. Okay, I can hear that you are saying what? Universe. Yes, we got it. So, as a result of which, what we say now is system plus surrounding is equal to universe. Okay, this is what we get. System plus surrounding is what? Universe. Absolutely clear? Very good. Now next thing is, if you can see this red line, okay, अगर ये लाल line नहीं होता तो हम differentiate नहीं कर पाते between system and surrounding. We cannot differentiate. So this red line is very important. It is responsible for differentiating a system from the surrounding, and that is called as a boundary. क्या बोला जाता है? Boundary. चौका छक्का लगाने का है यहाँ पर. So this is boundary. Okay. Now this boundary It's basically a line. But the characteristic of this line is it can be either real or it can be imaginary. It can be any one of which. I give an example so that it becomes very clear to you. A student is sitting in a classroom, the lecture is going on, the teacher is there. So he's supposed to focus on what the teacher is teaching. So for him, it's going to be the system is nothing but the classroom. Because as I said, system is something which is what? Specified. You did not specify surrounding. Once you have defined the system, automatically the surrounding gets defined. Whatever else remaining is nothing but what? Surrounding. So I need to define the system. So for the particular student sitting in the classroom, the lecture is going on. For that particular student, the system is a classroom. Outside the classroom, whatever it is the surrounding. So that means the classroom has walls. It has got windows. So which are real. And that are nothing but boundary. It's the walls, it's the windows which are separating the class from the rest of the other classrooms and everything else. Alright? So that becomes what? Boundary, which are something real. That's one example. Now you will say, alright, fine, समझ में आ गया. ये imaginary कैसे होता? ये real मतलब वास्तविक, imaginary मतलब काल्पनिक. ये boundary की बात कर रहे हैं और वो काल्पनिक कैसे हो सकता है? मैं आपको इसका भी उदाहरण दे देता हूँ. And that is, in a laboratory, if you just go, okay, and you are being assigned a practical, the teacher says that I'm giving you a liquid, take 100 ml of this liquid in a beaker, okay, insert a thermometer and start heating it and report me the boiling point. Alright, so everybody will go to their respective table and start performing this experiment. Alright, now it takes a particular liquid in a beaker and it introduces the thermometer and starts heating. Is it going to be like that as soon as the burner is on, immediately the liquid is going to start boiling? No. It will take some time. And the student is not aware about what is going to be the boiling point. So obviously, what is the ideal student need to do? That student has to focus completely on that particular beaker. Okay, and see at what particular temperature the liquid is start boiling. So for that particular student, the system is nothing but the beaker, the liquid and the thermometer. Rest everything is the surrounding. So he has to keep everything, all these things where? In the mind. Okay, that he has to focus only and only over here, nowhere else. So here he has created a boundary, but in the mind. And that's why that is what? Imaginary. Okay, he has not created walls around himself. He didn't say to the teacher, teacher ये सब मैं नहीं कर सकता, मेरी आजू बाजू में दीवार चुनवा दो, फिर मैं और मेरा बीकर बस, फिर मैं आपको बताऊंगा. ऐसा मुमकिन नहीं है दोस्तों. तो समझ में आया, ये दिमाग में इसने बाउंड्री बना के रखा है कि मुझे सिर्फ और सिर्फ इधर देखना है और कहीं पर भी नहीं देखना है. And this case refers to what? Imaginary. Am I very clear with this part? Yes. So this is what the basics of thermodynamics is. Okay, where we talk about the largest area, okay, ever possible is nothing but what? Universe in this particular chapter. Okay, extra universal particles. It's a topic of research, but we're not going to consider in this particular chapter. So that is the universe. Now out of that, the smallest portion if I take, which I'm going to specify, and I'm going to consider it with respect to thermodynamic parameters, then I call it as a system. Now एक और बात बताना चाहता हूँ यहाँ. जब मैं बोलता हूँ thermodynamic parameters मतलब temperature, pressure, volume, concentration, ये चारों प्रॉपर्टीज की पढ़ाई करनी है? नहीं. एक पर्टिकुलर हिस्से को अगर मैंने टेम्परेचर के नजरिए से भी पढ़ा तो भी वो सिस्टम बन गया, तो भी वो thermodynamic parameter बन गया. It's not necessary that I need to learn all the 4 properties. Any one of the property is sufficient. So I define system as a specified portion of the universe which is under thermodynamic consideration. The remaining portion which is there of the universe, excluding the system, is called as what? Surrounding. And therefore what we say, system and surrounding together comes out to be what? Universe, our most important formula. And then this red line is the one which is responsible to differentiate between the system and the surrounding. So it's a line which can be either real or it can be imaginary. I give you examples above. And those are called as what? Boundary. So this is what we have in the basic part of this particular terms of thermodynamics. We have system, we have surrounding, and we have boundary. So now my dear friends, आपको ये एहसास हो गया रहेगा कि क्योंकि ये चैप्टर का शीर्षक है, टाइटल है thermodynamics. and thermodynamic consideration हम देते हैं system को, and therefore in this particular chapter we are going to concentrate on what? System. Are you getting it, everyone? Yes.